Continuing my polynomial series in my 2020 distance learning, this is about factoring trinomials in the form x squared plus bx plus c, where the leading coefficient is 1. Here we go. Factoring, all right, we've been doing it recently, right, with that zero product property, right? We do something times something equals 0. Before that we factor, don't we? This time we're factoring trinomials, something plus something plus something. We've been factoring binomials, right? Taking out the greatest common monomial factor. We are now going to factor trinomials. And this is where it gets kind of cool. It's hard but satisfying. So to start us off, I'm just going to talk about factors. What's a factor again? Do you remember? Remember doing factor trees in grade 7? Kind of like this. If I was talking about 55, what are the factors of 55? You can do a factor tree, 5 and 11. All right, but if you're looking at all the factors of 55, what are they? Remember you used to list them last year? 1, 5, 11, 55. These are all possible factors, okay? And this is a factor tree. So 55, one way I can write this is 5 times 11, right? 5 times 11. 55 can be written as 5 times 11. What that means is we can say that 5 and 11 are factors of 55, right? In the algebraic world, we can also do this. X squared plus 10x plus 21 can also be written like that. It factors to that. Really? Do you believe me? If you didn't believe me, what could you do? We could do FOIL on this and see if it actually equals this. Let's try it. F O-I-L. First times first, x squared. Outer, x times 3, 3x. Inner, 7 times x, 7x. Last, 7 times 3 is 21. Collect the like terms, we get x squared plus 10x, 3x plus 7x is 10x, plus 21. Hey, it does work. So similarly, the same as what we did here with 55, how can we do this for this trinomial here? This trinomial can be written as a binomial times a binomial. So in other words, x plus 7 and x plus 3 are the factors of x squared plus 10x plus 21. The exact same thing as this can be done using algebra, thinking binomials and trinomials. Okay, so algebraic expressions can also be factored, and today we are factoring trinomials. And just on the topic of trinomials, a trinomial generally can be written like this: something x squared plus something x plus something. But today, see how we don't have the a there? All right, that's not a mistake. What we're assuming today is that there's always a 1 there. There's always a 1x squared. So today we're dealing with this situation, a is 1. Or in other words, we don't even have to write it, okay? So in other words, the number at the front of the x squared is a 1. So what's the skill we have to learn? Well, this is what you're going to get asked. Factor the trinomial. Let's try this first one. So like I said, trinomials can factor to a binomial times a binomial. Remember, there's a multiplication sign implied here, right? So it's going to be x plus something and x plus something. How do we figure that out? Well, this is the process. What we need is, we look at this number here. We need two numbers. Something plus something must equal that plus 8. Okay, we're looking for two numbers that add to give plus 8. And we are also looking for those same two numbers must multiply to give plus 12. What are they? And it's got to be the same two numbers. This and this has to be the same, and this has to be the same. What are the two numbers? Well, you just test. Let's give it a try. So what are factors of 12? 3 and 4. 3, 4. 3, 4. Let's check that. 3 plus 4 is 8? No. 3 times 4 is 12? Yes. That doesn't work. Both have to work. Let's try a different combination. I know. Factors of 12. 12 and 1. 12 plus 1. 12 plus 1. That's got to be the same. That's got to be the same. That works. Oh, that doesn't work. What else? 6 and 2. 6, 2. 6, 2. Let's check it out. 6 times 2 is 12. That works. 6 plus 2 is 8. Ah, that works. There we go. So these numbers here go up here. X plus X plus. These two numbers go here. X plus 6. X plus 2. Okay, and that is the answer. And it can be in reverse order. It could also be x plus 2 times x plus 6. Commutative property. It doesn't matter. Now, this method might be different from the textbook. All right, but believe me, I've been doing this a long time, and this is the best way. So if you look at the textbook, it might be different to this. But from my experience, this is the best way to do it. Let's try another one. M squared plus m minus 20. So we're not using x this time. We're using m. So it's going to be the same process. Equals something times something, a binomial times a binomial. This time we are looking for two numbers that add to give, there's no number there, that means there's a 1 there. We're looking for two numbers that add to give plus 1, and we're looking for two numbers that multiply to give minus 20. And it's got to be the same two numbers. Okay, I get it. 10 and 2. 10 and 2, 10 and 2. 10 times 2 is 20. Ooh, yes. 10 plus 2 is 12. No, that doesn't work. Let's try something else. So two numbers are multiplied to give 20. 5 and 4. Yes. 5, 4. 5, 4. Okay. Let's check these. 5 times 4 is 20. 5 plus 4 is 1. No, that doesn't work, but hang on. This time we've got a minus, so minuses can be put in as well. You can put a minus here and here, or here and here, or on both. Got to check all those as well. So, I know. If I put a minus here, what about that? Minus 5 plus 4 is minus 1. No. Minus 5 times 4 is 20. Oh, that works. But no, it's got to work perfectly. Maybe the minus here. Let's try that. 5 plus minus 4 equals plus 1. Yes. 5 times minus 4 equals minus 20. We got it. Okay, so this one is m plus 5 times m minus 4. That is the answer. And if you want to check it, just do FOIL on this and you'll end up with that. Okay, again, that could be the reverse order, but the minus has to be with the 4 and the plus has to be with the 5. That's the process. Let's just try a third one, for example 1c, just to make sure we're on the right track here. N squared minus 5n plus 6. So this is going to factor to a binomial times a binomial. What are we looking for this time? Okay, we need two numbers that add to give negative 5. So something must equal negative 5. And two numbers that multiply to give plus 6. Something times something equals plus 6. What are the two numbers? I know. 1 and 6. 1, 6. 1, 6. 1 times 6 is 6. Yes. 1 plus 6 is 7. No, but oh, hang on. If I put a minus, yeah, I'll put a minus there. That works. Let's just check though. 1 plus negative 6 is negative 5. That works. 1 times minus 6 is plus 6? No. This is not right. All right, well, we've got to try something else. What else can we do? Other factors of 6? 3 and 2. 3, 2, 3, 2. Let's give it a try. 3 times 2 is 6. That's good. 3 plus 2 is negative 5? No. This only works if there's both minus. How about that? Does that work? Minus 3 plus minus 2 equals minus 5? Yes. Now does this work? Minus 3 times minus 2 is plus 6. We got it. Okay, so this one is n minus 3, n minus 2. Okay, again, it could be switched. It could be n minus 2 times n minus 3. And that is the process. So these questions are asking for the factors, factor it. So the answer is just an expression with brackets. Okay, there's no equal zeros. There's no n equals anything. It's just the expression with brackets. Let's try something else. Example 2. This time we're going to solve an equation. So we've got a trinomial, but it equals 0. So remember, where does that come into play? Something equaling 0 reminds you of our zero product property. If we could get something times something equaling 0, then we can say that equals 0 or that equals 0, and then we get our two answers, our two roots, our two solutions. So all we're going to do is factor the left side. Let's give that a try. Still equals 0. And all we're doing, so now we don't have an expression now, we have an equation. We need two numbers that add to give plus 3. So something plus something must equal plus 3. And we need those same two numbers to multiply to give us negative 10. Okay, so let's go through this. Without guessing, we need two numbers that have a difference of 3 and can multiply to give 10. 5 and 2. Okay, so 5, 2, 5, 2. What about the combination? So look here, we've got something times something equals a negative. So one must be positive, one must be negative. If this is positive, they both must be negative or they both must be positive. When the product is negative, one must be negative, one must be positive. So which one's negative? We look up here. We're adding them and we're getting plus 3. So that means it's not 7. So there's going to be a subtraction here. So it's minus 2. Let's check it. 5 plus negative 2 equals plus 3? Yes. 5 times negative 2 is negative 10? Yes. We got them. So the left side is now x plus 5 times x minus 3 equals 0. And now we have our zero product property. Something times something equals 0, which means our next step, this must be 0 or something else, x equals or, and we're going to get two answers. What are the two answers? Put them up in the comments. So last lesson we had one of these and we ended up using our good old trusty zero product property. Oh, we have a problem here. We don't have a 0. That's no problem. All we're going to do is just move this 28 over to that side. Let's do that. Move it over. X squared minus 3x minus 28 equals 0. And now we have, like we had last lesson, we have it equal to 0. Now we just have to factor this. So we need two numbers that add to give negative 3. Something plus something equals negative 3. And we need two numbers that multiply to give negative 28. So something times something equals negative 28. What are these magic numbers going to be? So remember, it's going to be the same two numbers here, okay? This has to be the same, this has to be the same. Factors of 28 that have a difference of 3. So 14 times 2, does that have a difference of 3? No. 7 times 4, does that have a difference of 3? Yes, 7 4s are 28, so let's try 7 and 4. 7 and 4. So we've got a product equaling a negative, which means one must be negative, one must be positive. Where's the negative? It's going to be, if we're adding them and we're getting a negative number, that means the negative should be the bigger. So let's double check. Negative 7 plus 4 equals negative 3. That's good. Negative 7 times plus 4 equals negative 28. Correct. We found our 2. So this is going to be our next step. Remember, this is just an equation, and we're just changing what this looks like. X minus 7 and x plus 4. We now have our zero product property format. So what happens when something times something equals 0? Something times something equals 0 means that this could be 0 or this could be 0. And we get our two roots or our two solutions, x equals 7 or x equals negative 4. Okay, our little one-step equation there. So that's how you do that type of question. Same as last time, except just move everything to one side so it equals 0.